Hello friends, Assalamu alaikum. Welcome back to my YouTube channel. Well, if you remember, I mentioned there are three broad categories of machine learning, and if you counted with me, we already have covered those three. They are supervised learning, unsupervised learning, and reinforcement learning. So, why is there another video on the three categories of deep learning? You might be wondering. There are actually two special cases of supervised learning that I just wanted to briefly cover because they are very interesting according to me. So one is called semi-supervised learning, which is kind of like a mix between supervised and unsupervised learning. So in that scenario, we have some labels for some training examples, but no labels for others. So, semi-supervised learning is about using the labeled training subsets to label the unlabeled portion of the training set for which we don't have the labels, and then we can use them to make a better decision boundary. So, here's a sketch, like a very simple example. On the left hand side, we have a supervised data set. So this is strictly supervised, where we only have two classes, the class 1 here and the class 2 here. So these are our two classes, and we made the right side for the decision boundary like that. So again, this is a two feature problem, and our decision boundary might be just like in the center between the two. Now consider a case where we have more data, but now the data is unlabeled. So consider this unlabeled data. I have added it here on the right hand side in figure B, so it can be visualized better. So these blue dots are the unlabeled data points, and if I consider these unlabeled data points, a semi-supervised learning system may drive a slightly different decision boundary. So going from this figure A to figure B, I have not changed the position of class 1 and class 2 examples. However, I added these blue dots here, and the machine learning system may use them to put the decision boundary uh, more like this diagonally. Of course, it assumes or makes the assumption that this data point is actually one of the diamonds from the class 1 ones. It doesn't have to be correct, though. We don't know because we don't have labeled information. It's just an assumption, but we can actually still use this data to make assumptions, and this can potentially improve the system. So in this case, the decision boundary might be slightly different, and this might be slightly better decision boundary. So this is a special case of supervised learning that we just discussed. Other case of supervised learning is self-supervised learning, and this is a very popular area of research right now in deep learning. It's a very recent development and a very hot topic, and it's particularly useful also for training large models that need a lot of data and where we don't have access to these large amounts of data. So it's really about pre-training a model on a larger data set, and then you are fine-tuning it on a smaller set. So this is sometimes also called transfer learning, because we are transferring the data model from one task to another task. And why is it called self-supervised learning? It's just because we are driving utilizing label information directly from this data itself, rather than having humans annotating it. So let's talk about an example. You probably have heard of BERT, this language model. It's a very large model of billions of parameters. It's very hard to train. You need a lot of data for that. However, you don't have really millions of documents that are labeled with some classification task. So think of building a spam classification system. Like you want to build a system, a very good system, but you have a lot of parameters in this model. So you only have let's say 100,000 labeled images, like labeled emails, which are not enough for the system. So what you can do is you can pre-train it on all the text on the internet, and How do you get the labels for that? You make up some labeling task that is kind of contained in the data set itself. So in case of this BERT model, BERT model, what the researchers do is they mask, I think it's 15% of the words. So they give it the text, like some text on the internet, and they remove 15% of the words, right? And they let the system predict these words. So for that, you are kind of removing or withholding the labels, but you are using the data itself as the label information. So you have, let's say, a sentence, and then you remove, let's say, some parts of the sentence, and you have the model predict these parts of the sentence, but what the correct labels are. So in that way, you can teach the machine. Or another second self-supervised task within the BERT system is predicting whether a certain sentence is contained in the document. For example, if you have a document with multiple sentences, you remove one of these sentences or just take it out, and you make up a new sentence, like a second sentence. It's not in the same document. You just maybe make it up, or take it from a different document, let's say, and then you let the system predict which of the two sentences is actually in the real document. So you kind of make up these classification tasks by yourself. You create them from the data without needing a human to label it, because in that way you teach the model to understand the sentences. However, it still cannot predict spam or non-spam. It can only predict now missing words or the sentences, but it kind of helps the model to deal with language. So after you completed the training of this BERT system with self-supervision, you can take this pre-trained system and then fit it on the smaller spam and non-spam dataset to have a prediction task now that is a little bit different. But during this task, it learned how to understand language, and then you can apply it to the classification task to train it on that one. So this is called pre-training, and then you have the transfer learning, and then fine-tuning on the real data set that you care about. So this would be an example of self-supervised learning as well. Another case of self-supervised learning is from the image domain from computer vision, where, for example, you want to train a classifier to classify cats and dogs, but you don't have many cats and dogs in your dataset. It's a very small dataset, so you want to use unlabeled images, for example, to have it learn. So here you don't know what's in the image because you don't have the labels for that, but you can actually use the image still. So what you can do is you can divide the image into smaller images, and what I've shown you as an example is by dividing the images in 8, or this is actually 9 parts, and then you take out one part and you predict whether another part is a label on a neighbor or not. And you know the answer for that because you know this image and you have divided it yourself. You can write a Python algorithm for that. You know all the labels here, the labels 1 to 8, and you withhold this 9th part, and then you ask basically which so you have the this extracted part, you present it to the deep learning system or this convolutional network, let's say, and then you present it with another one of these. So you have 7 other of these image chunks. So here I have it next to it, and then you have it predict what label is it the 7 position, or like position 7, position 5, position 3, and so forth. So you know the answer because you were the one dividing this image. Let's say you wrote a Python algorithm for that, and you have the machine, or you teach the machine to predict the right position. So why is this useful? If you want to build a cat versus dog classifier, this is really like helping the system to understand what's in the image, or what's an object in the image, because it's kind of has to understand a little bit about cats here to put them in the right order, because like you have here, you have the eye and so forth. So it has to kind of somewhat learn the structure of the cat to put these pictures into the right order. And you have maybe also other objects like dogs and cats and other animals, so it kind of learns the structure of an animal. And it's like the pre-training task again. And then after this pre-training, you can take up your this network and fit it onto a smaller target data set that is, let's just say, concerned with animal classification. But again, self-service learning, it's like a very recent hot topic. We will maybe briefly revisit this in the context of transformers. It's like more like, I would say, a little bit of an advanced topic for this uh, introductory course. There are many different types of self-supervised learning approaches, but that would be another special case of supervised learning. So now I have covered all the broad categories of machine learning. So that's it for now. And in the next video, we will be discussing about supervised learning workflow.